BKW Physics. I'm Mr. McConley, and we're going to do a combo circuit again. We've done one before, but we're going to do another one. And this one here, I've drawn on the board. It has a 120 volt source battery. It's got resistor number 1, 20 ohms, resistor number 2, 16 ohms, resistor 3, 8 ohms, and resistor 4, 8 ohms. And the things that are in red, this is a problem I took out of the book, so we got V1, they called it. They want to know what the voltage is on resistor number 1, they call it V1. They want to know the voltage on resistor number 2, they call it V2. They want to know the current right here, and they call it A1, and it matches up to the branch tied to R4. And then finally they want to know the voltage over R4, but they call it V3. So because of the confusion of the labeling, I kind of matched up each of the red items with the total list of items that we can find from this circuit. And I wrote down, for instance, A2 is the total current going through this line. So that would match I total. V1 obviously matches V1, V2, V2. A1 is how much current is going through this branch. So that would match to the 4 category. So I4, the current in 4 is A1. And then V3 matches V3. So you kind of see where each of the red items that they're asking for matches up to our total scheme here. But whenever you're faced with a combo circuit and they're asking you to find things on the combo circuit, the first thing you want to do is find the total resistance. That's the tip of the day. So, how do you find the total resistance of this? Because it's a combo circuit, you have a series section and you have a parallel section. And what you want to do first, step number 1, is what is the total resistance of the parallel section? Parallel section only, so we're just looking at the parallel section. And since it's parallel, you have to use a 1 over R type of equation. So when I say, normally I say R total or R equivalent, but I'm going to put it R of 3, 4. Because what I'm trying to say to myself is, this is not really the total of the whole circuit, it's just the total of that parallel part. So R 3, 4, or more precisely 1 over R 3, 4 is equal to 1 over 8 ohms plus 1 over 8 ohms. So that's 2/8. Flip it, and you have to inverse it. The resistance of the 3, 4 section of this is, everybody, 4 ohms. So do I write that anywhere on my green chart here? No, because that's not one of the totals. That's just a step to get to where I'm going. So now I know that the resistance of these two combined is equivalent to 4 ohms. Now I'm treating this like it's one resistor. That's worth 4 ohms. And now I can add in series resistors together. So now I'm really finding the total resistance of the circuit. So I'm going to say, okay, the total resistance of the circuit is resistor number 1, resistor number 2, and this one I found a moment ago, we'll call it resistor 3, 4. So I got 20 ohms, just copying these off the picture, 20 ohms, 16 ohms is the next one, and the last one is 4 ohms. So 16 and 4 is 20, 20 and 20 is 40. So I have found that the total resistance of my circuit is 40 ohms, and this really is the total this time. So I can write it in here in green. Now, did that solve anything that the book was actually asking me to find? The answer is no. Sorry, it didn't. However, it allows me to find something that the book was really looking for, because since I have total resistance and I have total voltage, I can find total current. That's done simply by doing this. I total is V total probably goes into 120 how many times? 3. So we got 3 amps of total current. And that can be plugged into my chart. And that also answers the question of what will A2 be reading. A2 is the total current, so it will be reading 3 amps if we put an ammeter right there. Alright, so now we got to ponder what to do next. What to do next. Is there anything else that seems like it might be obvious thing to do next? Where do you want to go with this? Well, let's think about this. If the total current is 3 amps on this line, then how much current is on this line up here? 3 amps. I don't have to do any math on that. All I have to realize is in a series circuit, it says in your reference table that the total current is equal to I1 is equal to I2 is equal to dot dot dot. So I know from that law that now I1 right here, current right here, must be 3 amps. And the current right here, I2, must be 3 amps. And I'll even add that to my diagram for some more information. Because when I add it to my diagram, visually I can start to see something. I have the I and I have the R. And if I have both of them, I can find the V. Exactly. So that's going to be my next logical step. Let's find V1, which would be I1 times R1. I1 is 3. R is 20. 3 times 20 is 60. So I know that V1 is 60 volts, which has actually answered a question. We wanted to know what the voltmeter would be reading on resistor number 1, and it looks like it would be reading 60 volts. So let's move on and figure out the next one, because we can do that one also. We got V2, we got I2 times R2. The I2 is 3 amps. The R2 is 16 ohms. What's 16 times 3? Huh? 48. So I have found that this voltmeter right up here, which looks like I'd call it V2, will be reading 48 volts. Great. Where do we go from here? This is always kind of, for some people, a tricky point, but here's what I recommend you do. If you think of voltage, voltage has to be used up as you move around the circuit. So if you think of voltage, if you're coming out of here with 120 volts, and then we get to this point right here and we use up 60 volts, what do we got left after we leave? 60, because we lost 60 volts. Now we get to the next one, and we minus 48 volts. 60 minus 48, what do we have left? We have 12 volts left. So as we get past the series part of it, we only have 12 volts left. We used up 60, then we used up 48, we only had 12 left. So the next thing will allow us to figure out how much volts is pushing on each branch. And the next thing I'm talking about is when you look up parallel circuits, in your reference table it says that the total voltage is equal to the voltage 1 is equal to the voltage 2, etc. In other words, when you get to a parallel part of a circuit, if you know how much is coming in, you know how much is going to each of the branches because they're going to be the same. We're going to get, I'll write it flat, we're going to get 12 volts reaching R3, and we're going to get 12 volts reaching R4. So that just filled out another category for us. Filled out both of these. we got 12 volts for V3 and V4. Which is great, because we just found another one of the things they were asking us to find. They asked us to find how much voltmeter V3 was reading, and it's going to be reading 12 volts. Well, now we just have to put the icing on the cake, basically, because we can see that we have the voltage and the resistance, so we can find the current for this one right here, this I3. So let's do that. I3 is equal to V3 over R3. The V3 is 12 volts. The R3 is 8 ohms. What's 12 over 8? 1.5 I hear from the crowd, which is true. So, you now know that I3 is 1.5 amps. Now, to be honest with you, did we actually have to solve for I3? No, because the book problem wasn't asking for that one, so I could have skipped over that one, but just to be complete, because it only took 1 second, I just did that. But we do have to solve for I4, so let's show our work there. We got V4 over R4. The V4 is 12 volts. The R4 is 8 ohms, which is the same, 1.5 amps. So we have now found that the ammeter right there, because all the current goes on this branch, will also be reading 1.5 amps. And what we have successfully done by stepping through the process is we have found each of the things in this circuit, and specifically the red ones that the book was asking for. So for today, combo circuits, physics.